Greetings, this is Artie from Artifact Electronics. In this episode, I was going to try to meet a challenge, or more accurately a suggestion, which I received from a good friend and viewer of this channel. And let me quote from the message I received. Restore a PDP-10 and port some modern OS to it. Okay, just get one running. End quote. Seemed like a really interesting suggestion. Of course, I would need a non-functional PDP-10 in order to be able to fulfill this suggestion. So off I went to check my collection of stuff. I didn't find a PDP-10, which wasn't a big surprise because a PDP-10 is the size of several commercial refrigerators, and I should have probably seen one, or at least remembered if I had one, and just as expected, I didn't. I searched around some more, and the best I could do was this manual you can see, the PDP-11 processor handbook. The PDP-11 was much smaller than the PDP-10, based on a J11 chipset they built, and DEC sold a few 100,000 of these in the 70s. But I didn't have a PDP-11 either, and don't even think about simulators or emulators. It had to be the real thing. I found this diagram on the internet, which shows the initial 4 nodes of the ARPA network. The ARPA network, of course, evolved into the internet that we know and love, and waste countless hours watching videos on YouTube on. But this was in December of 1969, and looking through the list, the first node was University of California in LA using an SDS Sigma 7 computer. Second node was the Stanford Research Institute near San Francisco. That used an SDS 940. Next was the University of California at Santa Barbara using an IBM 360. And last but not least, the University of Utah, which utilized a PDP-10. The significance of that last statement is that the University of Utah is about a 20-minute drive away from the studios of Artifact Electronics. Well, if they had one in 1969, maybe they kept it. Maybe they hung on to it. I made some phone calls with high hopes, and the 2 people that didn't hang up on me right away basically told me I was out of my mind, and then hung up on me. So that didn't get me anywhere. But I decided to try the next best thing and take the 20-minute drive and go to the university surplus store. Maybe it ended up in there and was forgotten in some corner. I walked into the surplus store, asked the guy at the front desk, if he had any PDP-10s, and he just gave me a very strange look and continued working. So I asked him again, I said, do you have any PDP-10 computers? And he just kind of pointed at a bunch of shelves in the back and said, go look there. I got excited, I ran to the shelves, but those shelves look awfully small, and as it turns out, there were like 200 Dell computers on there. And I guess all he heard was when I said computer, and he pointed me there. And I walked around a little bit more, but no sign of a PDP-10, PDP-11, or PDP anything, which didn't really surprise me, but we can always dream, right? Having failed in my original quest, I decided to walk around nonetheless, and there was a bunch of interesting stuff in there. But the way this place works is there are public sale dates on it. And by public, it's people like me. Everybody else can walk in there and buy anything they want at any time. And one thing I've experienced is the good stuff. There is good stuff staying around, but if I ever go there on the public sale dates, for some reason all the good stuff's already gone. So I've never hit it big there. But, of course, this time I went and I saw this shrouded for dramatic effect, sitting between a gas chronometer and some piece of medical equipment with an unpronounceable name. But this is what it was. It's a Tektronix 465M oscilloscope. Some of you may go, wait a minute, didn't we just see one? Yes, you are absolutely right. And for comparison's sake, here it is. That's the original. Well, original, this one was done in episode 18, fixed, and there it is. And I found its twin brother. I figured there must be a real good reason why this is still here. Of course, let me add that, as usual, it was pretty filthy. But the most annoying part of it is that the cabinet was pretty much covered in a gray, fuzzy material. And it took me some probing to find out that it was what seemed to be adhesive residue. So I think what this thing was basically stickered wall to wall, at least on the top, and somebody pulled off all of the stickers, but left all of the adhesive behind, and that attracted all sorts of things flying in the air and turned into an interesting covering. The public sale date was on there, and it was like 2 months in the past, and the price was scratched out, and it was kind of strange, but I asked the attendant, and he came and looked at it and said, oh yeah, this has been sitting here for a while, and mentioned, I think he said it was like $20. Well, for $20 I could buy this, rip the cabinet off, and have a parts machine for the one I already have. So first I thought I should go and test it, but for $20, $20 is probably worth one of the custom chips in there, at least. And second of all, because it was kind of sticky, I ran the risk of picking this up and having it permanently attached to either myself or the car. So I got a plastic bag, put it in there, and took it. So I literally bagged it and took it home. When I got it home, I could not get myself to just take the case off and throw the case pieces away and keep it as a parts machine. So I went ahead and attempted to clean it up. I tried several things, but I found a citrus-scented solvent for adhesive residue, and with that, and about an hour's of elbow grease and lots of paper towels, I was able to get all of that residue off, any remaining stickers on the side, and clean up the front panel, and it actually, as you can see, looked pretty nice. So I think at that point I didn't consider it a parts machine yet, but let's go have a look and see what this does. So when I turned it on, I got these somewhat fat traces, and trying to focus them did this. So, well, that trace on the bottom is kind of sharp, but then channel 1, as you moved it up, it got fatter, and it would only move down this much, and affect the position of channel 2, and channel 2 would kind of get sharp as it got to this virtual lower limit here, but then as you moved it up, it also got fat. And changing the intensity moved them around, and changing the focus moved them around. So I think we had a serious voltage problem here too. And I began to think, well, let's see if lightning strikes twice and check that capacitor that was bad in the original one. I'm going to sound like a broken record, but make sure to watch episode 18 before you go on here, because otherwise anything I say after this point is not going to make a whole lot of sense. So, everybody's back from having watched episode 18. Great. As you can see, the exact same capacitor I did on the original was bad on this one too. I measured it in circuit. Of course, I had to go through the rigmarole of, again, removing the bottom, removing the vertical board, this one, and, doing all that good stuff. But basically, I was able to remove the cap. And here's a cap that I pulled. And this one also had something that looked like leakage residue on one of the legs. But let's see what the meter has to say here. Of course, that you can't see. Maybe this you can. But hooking this up, so that little two-tone thing usually implies there is something wrong. Now this one, the value is spot on, but the ESR is way too high. So it's turning into a resistor and doing nasty things. Now, for comparison's sakes, I pulled the capacitor from the original one out to see what that one said. And that one, on the original one, the capacitance had actually dropped significantly, but the ESR was still sky high. So I think that was pretty lucky, because probably found the problem. Didn't take me a whole lot. So far I've invested time into acquiring and cleaning it. And this one I was kind of used to. So it didn't take that long. I got a new cap in, and then I happily turned it on. Well, it didn't work. I turned it on, and it was exhibiting pretty much the same problems again. Now, I did go in, of course, and check the 95 volts over here. So let's have a quick look at that, and have a sanity check here to make sure that I'm not losing it. Oh, it is still on. And so measuring the 95 volts, it's right on now. And yes, I forgot to mention the 95 volts was just under 90 volts before. And measuring the AC component, which is well within spec. So that definitely needed fixing. So fantastic. So I turned it around, turned it on, and it exhibited the exact same behavior. Had those two ugly traces, and as I moved them up and down and tried to focus them, things were all over the place. So there must be some other bad voltages in here somewhere. So I started probing around. So it does turn out that lightning can strike several times, because remember last time I ripped off these two wires, which are the vertical deflection drive for the tube. Well, I thought, let me check it. And even though both wires were tucked under there, when I yanked this one with tweezers, it was free. Well, that's very interesting, and Let's see if I can actually illustrate this. It's very hard to do, but what happened here is that the pin on the PCB that this plugged into, you can see the end of the pin still being in the connector. This connector broke off. I mean, the pin itself broke off, and this thing was floating free. So, fortunately, the wires hadn't come loose from the CRT, but this one, the pin had broken off, and this was floating around. Now, that's a pretty serious defect here and would cause all sorts of problems. And I'm trying to reason how that could have happened. But then I remembered, when I opened the case, there was a little bit of deformation in the in some of the brackets. And let's see if I can show that a little bit better. And that's basically these brackets over here. It looked like it got dropped somewhere or impacted here, because once I took the bottom off and then tried to put it back on, the screws wouldn't fit. It was the metal parts were deformed. I mean, they bent back pretty easily. It's aluminum, but it did imply that there was an impact there. Then I saw something else. If you see that shaft running over here, that is the power switch. And that had basically, it was laying here and it was running diagonally at an angle. That didn't look right. And then I noticed there were these notches in the board here. And that's where the power switch belongs. So something had knocked that out of place. And I think a really good explanation would be that this got impacted somewhere over here, bent these, and knocked this out of its position. And that would probably explain how the pin on the vertical connector could have broken off. So, of course, now, as I complained in the last one, I have to try to finagle this in again. I'm going to try not to disassemble any of this. No, I take that back. I'm going to have to disassemble this because I have to take this board out and solder this pin that you see sticking out back into place and then plug this in. Alright, so I fixed it, but I'm not going to show the actual procedure because of foul language used due to bad hand-eye coordination, making that segment inappropriate for public viewing. But essentially what I did was I was able to stick a soldering iron in there. I pulled the broken pin out of the connector and tack soldered it back to where it had broken off. It sits at like a 30-degree angle to the board. I had to try a couple of times making sure not to burn anything around it. But finally it got in there, and I yanked on it with a pair of pliers on the pin I had soldered back, and it seemed solid. Then I inserted the connector back in the pin and set everything upright. So let's see if that was the problem. Power switch is very smooth now since it's sitting in the proper slots. And what do we get there? We get a fat trace. What is it? It's number 2. Is there a number 1? There is. Nice. So, can we focus it? Yes, we can. For a razor-sharp image. Beautiful. Now, do we still affect? Can we move both traces off the screen? Yes, we can. There seems to be a little bit. No, there's no effect. The first trace is rock solid there. And the same with this one. Does it go off the top? Go off the bottom? There you go. Now we need to run some signals through it, but it looks like number 2 is fully functional and just transitioned from being a parts machine to being a full-fledged member of the oscilloscope arsenal. So the scope's rated at half an amp power consumption, and both traces are up. Intensity is normal, focus is normal. Let's see what it's consuming. So we are at 117 volts, and it's consuming 0.37 amps. So everything seems to be working fine. Oh, it's approximately, 26% under max consumption as far as the current's concerned. So I didn't break anything else in there, and things seem to be working just fine. One thing that I had glossed over in the first episode was I talked about how to clean sealed pots, but I never showed it to you. So let's remedy that. So there's 2 pots. So what you do is you take a tissue, a paper towel or whatever, and you stick that around the pot like this. And the reason for that is I try to prevent overspray going all over the board. You then use your favorite contact cleaner and spray a squirt right where the shaft enters the pot body, or the bushing here. And then turn the knob several times, and then let it sit like this for a while, because gravity will do its job, and the contact cleaner will seep in through the small margin here. And after a few minutes, turn it again a few times, and you should have a clean pot. And remove this, of course. Would probably prevent the overspray from going everywhere else. And apply that to all pots. And the rotary switches you can spray directly, because they are usually exposed to the elements. Here's the brothers in arms shot. This is the original, this is the new one. And the way I distinguish between them is I left the expired calibration sticker on the new one. And I'll probably put a big number 2 on it, and that way I can tell the difference. But they look the same, not virtually. They look the same, the traces. And one last thing, we should probably put a signal into the new guy and make sure that it's actually able to display signals. So wait, let's put this one down here. And this one up here. Switch them both to DC. Leave them on 0.5 volts. Turn on Mr. Noisy. Mr. Noisy is far from the desk right now, so hopefully you can't hear him. And there you go. I'm displaying 1 kHz at a 1 volt signal. There's your sign. Of course, there's your square. Well, I should probably make them a little smaller so you can tell that there's 2 of them. And my own personal favorite, the triangle. So, yes, it needs some more extensive testing, but I think that's good enough to initially say that he's fixed. Now I got two of them. A few random items. I didn't mention what the cleaner was I used, the citrus solvent. It's called Goo Gone. I don't know if this is available outside of the US, but anything, you know, I mean, the citrus part doesn't do anything. I just think it makes it smell good. It's still got lots of VOCs, or volatile organic compounds, in it. So when cleaning this up, I probably shortened my life, but hey, look at this trace. That was probably worth it. And second of all, the contact cleaner I use is Deoxit, which I think is available more widely than just in the United States. But quite frankly, for this application, for sealed pots and for the contacts, if there's no corrosion and stuff on them and they're just a little bit dirty from use, I think your plain contact cleaner that you can buy at your electronic supply store, or alcohol for that matter, high percentage IPA, will do the same job. And I think that just about wraps it up. Thanks for watching. I hope this was as enjoyable an experience for you as it was for me. I mean, I did get pissed off when I fixed the cap in here, and it didn't make any difference. But fortunately, the problem was quickly found and fixed, and it's great now. I mean, the Tektronix scopes, I can't toot their horn enough. They're just, the displays are absolutely beautiful. And for analog, yes, for scientific applications with modern equipment, it's not going to beat a newer scope. But for anything analog, this is absolutely beautiful. Thanks for watching. I do appreciate your support. If you liked what you saw, give me a thumbs up. And if you haven't already, go ahead and subscribe. We'll see you soon.